Hello guys, back with another live stream. So till now we have got a strong hold on recursion and we have solved some patterns of recursion. Now I'll be moving to subset sum pattern. Let's see what it is. So given 2 and 3, this will generate all the power set of this and sum of all the power sets. The answer will be 2 raised to n, that is 2 square 4 elements. What about here? So output is 0 1 1 2 3 4 5 6 7 8. Possible subsets are 0 no elements, 1 either one of the ones, 2 the either 2's, or considering 2 plus 1 3 and their combinations. Okay, so this is subset sum. Wait a minute, I have to write code here. So the brute force that comes in my mind is generate all the subsets using power set, using recursion or bit manipulation or anything. So that will give me the actual subsets and then I'll sum all of them and write the answers is what comes in my mind. So shall I write the code for that? So let me write a code for generating power sets. How did we do this? So in order to generate power set, let's use the pick and not pick method. I'll call a backtracking function. Okay, and the things that will change in this will be the index. Yeah, index will be changing. And what? Let's keep index. So when will it end? When if index is equal to n, return. Okay, I'll take the answer as a list and then I'll append. Let's take a temp list, temp answer. If index has reached to the last position, whatever is in, I'll do answer dot append sum of temp answer. Okay, so this is my exit condition. What the hell? Indentation is ducked up. Okay. And then the cases of not picking and picking the element. So when I don't pick, what I'll do, I'll just increase the index and not include the current index in the temp answer. And for picking, I'll add temp answer dot append the array of current index, and then I'll again call this function backtrack with my increased index and new answer, and then I'll pop. So this is done. So this is how a backtrack will be called. I'll call backtrack for index is equal to 0. This n is not defined here, so n is equal to length of array. temp answer will be empty first. No, not return. I'll run this once and then I'll return answer. Let's see. Am I missing something here? TLE on my first output. Input was just 2 and 3 and it gave me TLE. Is my function not returning anything? Oh, after the base case, always put a return in order to stop the program. Now let's see what the other problems are. Okay, I think this will give a TLE. Oh, it didn't give a TLE. Why didn't it give a TLE? Constraints area of I is, but in order to generate all these subsets I'll need 2 raised to n, and n is just 15, so 2 raised to 15 is how much? 2 square, 4 raised to 4 raised to 7, so it's obviously less than 10 raised to 8 maybe. So that's why I didn't get a TLE. Is there any other way to do this? So once I submitted it, right, I'll check the editorial. Some 1, some 2, some 7, some 5. This is what we did, but we are not increasing sum with every iteration. We are just summing up everything at the end in this way. So what is this extra space that we are using for temp answer? So let's see what they have done. They have taken another parameter as array index current sum and result, and we have taken index and this. Okay, result dot append current sum, so they're carrying this current sum every time. Okay, let's improve our code. We'll add one more thing here, total. Let's give it current total, and I'll straight away append current total here, and in every call. So for not picking, current total will be same, and here current total will be increased by this thing. And current total in the start will be 0. I'll return answer. Beautiful. क्या हुआ भाई? think we went too quick. Current total, append current total every time, and backtracking, sorry, not picking. Case is same as calling it with current total, and do I even need to add this temp answer? No, right? Don't stop me now. Index 0 and start total will be 0. What happened? Define backtrack index total. What is this? Nice. No other approach. What is alternate approach? Iterative approach to solve this problem while visiting a new element. Okay, what was the space complexity? 2 raised to n as we generate all. Space complexity as we store all the subsets in the vector whose size is 2 raised to n and recursively call the stack. As we store all subsets in the vector whose size. Okay, for it. S is equal to 0. Find range n is the number of elements, v is equal to the length of s. Who is s? All the subsets generated till a particular index. Is that the thing going on here? So initially without having anything, I'll have 1. Okay, t in the range v s dot append s of t s of t plus area of I. But so let's see. Find range n, v is equal to length of s, and range n, v is equal to length of s, length of string v is first 0, this y is equal to 0. So for t in range v, append s of 1. Wait a minute. S of 0 plus array of 1 0. So first element is added at this element with previous subsets. Okay, and then once this is done, now we'll again go to this. I becomes 2. I becomes 1. So my first element is, say, 1 to 3 was the array. Then the next element, I, s of I will be 1. So v is equal to length of s, v is equal to 2 this time. T is 0, s dot append s of 0 plus array of s of 0 plus array of, what was I? I was 1. Okay, so both of them will be added. How is this done? So let's open Paint. So first 0, then 1 will be added, then I'll add both of this, and this will be another 1. But it shouldn't be, right? Then no, s of t plus array of I is 2. Okay, so we are adding the current element to all v's till now. Okay, dumbass. So 3 will be added to 3, and then 1, and then 2. It's 2's chance. 2 will be added to 0, 2 plus 1 3, 2 plus 3 5, 2 plus 4 6. These are all the additions. 3 was with just this. Okay. Yeah, nice. Subset sum 2. What happens in subset sum 2? Is there subset sum 3? There's combination sum 3. Let me check the stream real quick.
Musical scales. Major.
Let's go. Why don't you read chat's message? Oh, sorry. Oops. Aditya Suryavanshi. I didn't see this. Subset sum 2, yeah. What is subsets 2? Okay, so given an integer array nums that may contain duplicates, return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return solution in any order. So yeah, so we've solved combination sum problem from that. Okay, so first of all, I will start writing code for generating all the possible subsets. Okay, and that code starts with answer. I have answer just like previous solution. I'll just code the same solution up. Answer, and then what did I have? And is equal to length of nums. And then I have defined backtrack with index, and what do we have here? Index, and what was the other changing parameter? Sum. Oh wait. Return all the possible subset. The solution set must not contain duplicate subset. Return the solution in any order. There's no sum required here. So we will need a temp answer. Okay, temp answer here. Now the base condition is if index is equal to has reached the end, then what I'll do is I'll straight away put this temp answer also no append temp answer. The other thing, I'm not considering the case for duplicate subsets as of now. First I'll code it up and then I'll check for duplicates. Okay, and then normally the not big case and big case. So not big case, what did we do? Not big case, what did we do? Call the same function with an increased index plus 1. No change in temp array, and in big case I'll call this, I'll increase this, and temp answer. So I'll do temp answer dot append what the nums of index, and then I'll pop out temp answer dot pop in the same index that we had. And one thing was exiting the loop here, and then in the end calling the backtrack function with the default parameters, index as 0, temp answer to be an empty list. Oh, also I'll append a copy of it using this. What else? So this will probably return me the wrong answer, that is along with the duplicates. Hmm. So what did we have here? We had two duplicate strings. Yes. So one way to do this is considering just unique elements in this. How can we do that? What if we convert this to set in the start? Nums is equal to set of nums, and n, so we do this before this. Hmm. Hmm. Bruh. Hmm. What do you mean? Okay, we still are getting the wrong answer. So converting to set won't help. How to solve this? Okay, so in not picking case, what I will do is I will skip it till I I'll skip it. First of all, I'll sort nums dot sort. Now that I've sorted everything is in order like this. After that, I consider empty. Then I consider 1. Then I consider 1 and 2. Okay. But then, if they are same, then I will skip the not big case, because that's giving me. Would I run this? No. Okay, I'll run this. We'll see what is the difference that we are getting. Yeah. So this 2 is coming. It is because we skipped in not big case. This ran twice on these two places. So you can skip that using while. Mm, next index is equal to next index is less than and both are same. I'll just keep on increasing. And what? And nums of next index is same as nums of current index. I'll keep on forwarding next index plus equal to 1, and then in backtrack I'll just call it with next index. What about pick case? Should I be worried? If I skip in pick case, then I won't get this answer. So let's run this. Okay, let's go. So this was solution for subset sum 2. Is there any better solution for this? Tutorial is locked. Submission solutions. C++, C Python solution. General backtracking. What? Combinations, permutations 2. Subset 2, combination sum. Oh, I have taken solutions from frequently asked backtracking, which I found helpful. What has this board done? Is this subset sum 1? This is subset 2. Okay. They have sorted the nums, and Server.dfs nums 0 result.append path every time, and then for I in range index to length of numbers, if I is greater than index and nums of I is equal to I is greater than index and nums of I is equal to nums, then they will continue, otherwise it will call self.dfs nums I plus. Okay, whatever. I find my solution more intuitive. Combination sum 3. Find all valid combinations of number of k numbers that sum up to n such that the following conditions are true. Only number 1 through 9 are used. Okay, each number is used at most once. Okay, so we don't want duplicate numbers. Return a list of all possible valid combinations. The list must not contain same combination twice, and the combination may be returned in any order. So k is equal to 3. K is the number. K, find valid combinations up to of k numbers that sum up to n, of k numbers of 3 numbers that sum up to n, says that. What do they mean? So any numbers that sum up to 9. So taking first example, n numbers that sum up to 7, 1 to 9. Okay, so in order to understand the problem, 1 1 1 1 1, first example was, that was the first example. So when n is equal to 7, then n into 1 plus 1 by what? There was a formula for addition of natural numbers. N into n plus 1 divided by 2 something. Is this true? Let me check it once. So 1 2 3 4 4 5 6 7 8 9 10 is equal to 10. Was this formula 4 into 5 divided by 2? 5 into 2 is 10. Yeah, okay. So sum of these numbers was 10. What do I understand by that, bro? Anyways, I don't think this matters. So if n is equal to 7, if sum is 7 to be found, let's list all the numbers till 7 for now. We'll optimize it afterwards. So this is my possible list, and from this I have to find subsets of size k subsets to have a sum of 7. Is this what I have to find? Yes. But how do I find subsets of what's the range of 7? K can be between 2 to 9. Okay, and numbers can be till 60. This constrained space forces me to think this in the way of DP actually, but I'm not yet that good in DP, so I don't know. Try to think for 5 more minutes and then just jump to the solution. And what's happening here? So first thing, if k is greater than n, I straight away, no. Is this true that if k is greater than n, k is greater than n, then anyways sum can't be k is greater than or equal to. Now what if k is n is 1, k is 1? If k is greater than n, return this can make one of my test case pass. Let's go. Anyways, apart from that, what should I do? So shall I just find all the subsets of this number of size 3 and then find the sum of them? Okay, let's try to do that. So in order to find all the subsets, I'll just copy paste this solution that we solved in the previous question. Okay, so here this is my answer. This is length of nums. Nums.sort is not required here. Now here I have to make my nums, right? Will I make that? Nums is equal to I plus 1 for I in range n. Okay, so this will be 1 2 3 4 5 6 7 8. 5 6 7. And then what do we have? We found our nums. We are backtracking. We are having temp answer, and we will keep target. We need a target here, right? So if we have reached index n, first thing first, if I'm reaching index n, what does that mean? That means I will straight away return. Okay, then if target is equal to if length of temp answer, if length of my temp answer is equal to k and target is equal to what, n, then I will add answer dot append temp answer, and then I will end that particular recursion. Is this true? Yes. Then we don't care about all this. Backtrack, next index, index temp answer and target, and pick case will be adding temp answer and my target plus nums of index. And then initial target will be 0. Let's see what happens. Maximum recursion depth reached. Yeah, don't forget to increment the index. What happened? So my output was nothing. Why? Isn't this the code for returning? So what's happening here? Length of temp answer is equal to k. Yes, and target is equal to n. N is the target, right? Then I'll add to the answer this, and if index is equal to n, then I return, because we don't have to access it. This is correct. Is this correct? Why am I checking? Let's check target first. I don't think this matters, but for mapping this in my brain, okay, if my target reaches n somehow, and if and only if the length of my temp answer is k, then I'll add it to the answer and return. And not picking is just ignoring the current index, temp answer and target. Otherwise I'll increase temp answer to have length of index and index plus 1, and I'm increasing the target to here and popping it back. What is wrong here? We'll debug it for some time. Yeah, this is what I'm looking for. So pick, ignore pick, and my temp answer. Oh, copy of temp answer. And here we go. Will it give TLE? Because I have traversed all the cases available. Oh yes, it's a TLE. So till what point do I have to check it? Find range n by 2. One, two, three, four. This is the optimization that I was trying to figure out by this. List index out of range. Bro, what? Okay. And then n is equal to length of nums. No, bro. I have to change this name. Index is equal to real index, okay? And then while checking this, if target is n, yeah, that is the n I care about. Let's run this. Is it running? Bruh. So n divided by 2 plus 1, will it run? Oh, okay. Should have run because now let's jump to the solution. We have wasted a lot of time. Solution Python. Couldn't show me all this. Bro, what stack? Stack is 0. Okay. I think stack is the temp answer, and then if length of temp answer is k at any position, if target is 0, then only I'll append and I'll return. That's one thing. And then okay, so but what is nums? Oh, num is 0. Wait a minute. Why is it always 10? Between 1 to 10. Oh. Okay. A minute observation that I missed here was this. So the numbers can be this. Come on, man. And then this. So 3ms, this was me. Why do they use this for? So this is the pick case, picking partial number plus return, and what is this? 430. What else? Last number plus 1. Last number plus 1 means index plus 1. Whatever. Combination sum is done. Now I will solve this. Next question. Letter combinations of a phone number. Bruh. phone number ही छपवा दिया ये लोग ने. Okay. Let me quickly share my link. Letter combination. Given a string containing digits from 2 to 9. Inclusive. Okay. Return all possible letter combinations that the number could represent. I return the answer in any order, mapping of digits. So if we want to press 2 and 3, we can have ABC 2 and 3. Okay, we are pressing 2 3 times, then it will give me C, and D 2 times, then it can give me. Oh, interessante. So whatever numbers will be given, what can be the length of digits? Let me see first. Digit length can be maximum 4, and so 4 this 3 raised to 2, 3 square, 1 2 3 4 5 6 7 8 9. 3 square is 9. Similarly, three power 4, 3 square 9, 9 square 81. So my length of output can be maximum of 81 answers. Then Useless information. Thanks for sharing. What else? What else? 2 to 9, no? Is this a hard problem? No, medium problem. A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. First thing first, in order to number 3, do I have to return the output or number of return the answer in any order? Okay, how do I approach this? So the input space is, so this is purely a combination sum. No, 2 for digit in digits. I'll get a digit 2. Okay, so I'll make letters list, and then that, what are my first 3 letters? ABC. Next 3 letters DF, EF, GHI, JKL, MNO, PQRS, TUV, WXYZ. So index, this is 0th index, na? So if digit is 2, then letter is equal to letters of digit minus 2, correct? So if my digit is say 3, then letters of 3 minus 2, 1, 0, 1, DEF. So 3 is DEF, right? So my letter will have a string, letter is equal to DF when digit is equal to 3, right? So we figure out this, length of digits will be 4, that's not a problem. Now what can be so now that we found out, I'll append it to, I'll make a temp variable, temp list, to temp dot append. Okay, so after this loop, my temp will have something like, let's take for first example ABC, DEF. So this is my temp, let's say. Okay. So what is the main question here? I have to find all the combinations for ABC and DEF combined, wherein I have to take any of the elements, any one of the elements at a time from each one. Okay, so it's about picking and not picking, but we are picking only one at a time, right? So pick and not pick won't work, right? The only thing that we have to do is, can I put this in a simple for loop? mm. So anyways, I need one from everyone, right? I need one from 3 and one from 3. Bro, this is something easy, but I'm confusing myself. Let me think. This is 3 power n. Oh, okay. So instead of pick and not pick, the options that I have is pick first, pick second, and pick third for each one of them. Okay, so recursion. How do you understand this in interviews? Define backtrack. Okay, backtrack will be given the temp. What will backtrack do for the temp? So backtrack will for no for temp. Choose. Yeah, what did I think of? Choose first. Choose second. Choose third. And this is the answer builder. Okay, I'll write the answer here. And so when will this stop? So let's say passing this string, right? This temp. So it will choose first, choose second. So for I in do I need backtrack for this? I'm taking too much time. Binary exponentiation. Oh. Binary exponentiation. This is what? Triple exponentiation. Can you use something like that? What was in binary exponentiation? I don't remember anything from that. So let's head back to binary exponentiation. Power of xn. Count good numbers. Going back to this problem. Is equal to return half is equal to. Oh wait, this is not. Or can I use bit manipulation here? I can actually use bit manipulation. What are my bits? But What is a modulo 1? Is there something like that? Python interpreter. A modulo. No. A and 1. A is not defined. Okay. 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 Enough of that. Let's jump to solutions. Can't do this. Backtracking. The pros leverage recursion to all possible combinations. Create recursive function that takes the current combination and the next digits to explore. For each digit, iterate through its corresponding letters. Okay, that we can do. So, index, temp, and answer. For each index, I'll give 3 options for it. Okay, it will be temp of index, choosing first. This will be temp of index, choosing second. This will be temp of index, choosing third. And at some cases choosing fourth. But this is temp of index, choosing the fourth one. Don't stop me now. Temp of index. And there is something that we are building along the way. So I'll take a string builder also with this. So what I do here is string builder dot string builder plus this string builder dot join. Control C, Control V, Control V, 1, 2, 3. So instead of string builder, I don't need to pass answer in this, right? Okay. Who is temp? Why do I even need to pass temp in this? Bruh. The only thing that will be changing is index and this, no? So exit condition, if what is index plus 1 every time, right? If index is equal to length of temp, what is length of temp is same as length of digits if length of then I'll return answer. Now then I will answer dot append string builder, right? And then I'll return this function. Otherwise I'll choose this once. Oh, wait a minute, I'm choosing it, but after this function runs, what will happen? This function will go in this and it will increase the index by 1, right? But at the same time it will run the others, right? I don't want that. So बड़ा मोमेंट हो गया. रोब्लॉक्स में गेम बना, वेरी नाइस. हमारे सब्सक्राइबर्स are from different tracks, so if any of this recursion runs, how the fuck? Let's say backtrack is called for index 0. Index 0 and string builder is nothing, and I return answer. Let's run what I've written. Beautiful. Is this allowed? Don't stop me now. Don't stop me now. Integer of digit. Probably happened here. If length of what? Temp of index is greater than 3, then and only then I'm gonna run this. Okay. Who is this? Okay. One edge case. If length of digits, the fifth length of digits is equal to 0, return this, and then we'll get two test case pass. What happened here? D, E, F, T. What about the other letters? The fuck is this? +1. Nice, good boy. What is my string builder doing? String builder, okay. Now let's do a test run for this thing. Okay. Test run for this thing. Digits are 2 and 3. Okay. So here इधर skip कर दिया. Temp answer for digit in digit 2. Temp append letter of int of 2, 2 minus 2 0, letters of 0 is ABC, temp में append हो गया ABC, and then दूसरा 3 temp में हो गया append D, ABC and DEF. Okay, ABC and DEF. From that, every time DEF was added 3 times. But what about the first ABC, man? Where did my Shaila go? So backtrack. I started it from index plus 1, sp dot join temp of index 0. Okay, what was ABC, no? 2, it was ABC. Okay, the string builder. Bruh. Oh, I knew it won't work. Let's our Lord ChatGPT to help me. You're building a solution, got a phone number. हाँ भाई, bro knows everything. But a few things. Incorrect uses of string dot join. sp dot join. Join for joining list or return into a string. Oh, so you say I should have done just. Okay. Will it make any difference though? If you say so, I'll add this. Next, suggestions. Holy sh! So it was just a plus sign. Hardcoding numbers of choices. Okay, look at the cleaner code. If not digits, return this. Good. Then this is same. Mapping. So mapping. Phone of int of digit minus 2 for digit in range. What do you mean, bro? Okay, that's it. So this is my temp. Backtracking end path. If int is equal to length of digits, answer dot append path. Temp return. Method answer dot append path and return. But I don't use this. And for character in mapping of index, backtrack is equal to path plus character. This is character. So this is happening for every mapping of index. Temp of int. Temp of int. Temp of int की length. Character in temp of. Oh, bro. Okay. Anything that makes the code work. It's close enough for this. So this question showed me the way of calling multiple. multiple recursion calls. Could this be done differently? Going back to going back to कहाँ गया भाई? Going back to the question. Going back to the solutions. What has bro suggested? Backtracking approach. Approach leverages recursion to call all possible combinations. We function. This program builds a combination of differences. Backtracking approach relies on recursion to build both the process and time complexity. First of all, don't show me this. Okay, bro, phone mapped it. Not digits. Next digit. Oh, taking one digit at a time. Next digits किधर है भाई पहले? These next digits, all digits. So I'm taking first digit and then what am I doing? Calling it from next. For letter in phone number map. So let's say this is 2. To a phone map will give me ABC. So for A, backtrack is equal to combination plus letter and next digit. So ABC, 3 different function calls. What is iterative of for digit in digits, new combination. For combination in combination. For letter in fuck you man. ही बाकी था. ओ माय गॉड, और इतने सारे प्रॉब्लम्स है भाई. और see, we are almost close to 200. 6 attempting. The fuck am I attempting? Dang. Anyways, where are the ones that I'm attempting? How do I see the ones I'm attempting, man? What? Okay, new month. Previous month. 9 hours ago. Filter. Attempted. Name of my trees. What is subtree? Bring matrix. Carpooling. Some other day. Minimum number of k consecutive. Let's look at this. Oh my god. Never mind. Let's not take any gay decisions. Or shall we? Fuck off. Straight to the question. Palindrome partitioning. Beautiful question. So beautiful that I don't even remember solving it. Given a string S, partitions S such that every substring of the partition is a palindrome. Return all possible palindrome partitioning of S. Huh? So my first answer will always be the single element partition. The next will be the double element. So, this I can do, but what about the next partitions that we have? Partitioning them in such a way that each of them is a palindrome. So one thing is that what if I were to never mind. So they shouldn't repeat out. So what if it is A B C? If A B C is the question, then A B C will come in the first, right? The second answer that we have will have A and then B and C. My brain hurts thinking about this. How do I think about this? So that's it for today, guys. I can't take this anymore. It's 5 a.m. It's time to sleep. Let's see if anybody is online. On my stream. Nobody except me. Thank you